Hey guys, today I'm going to be doing a video for the channel on shimming. The basics of shimming is pretty simple actually. Basically the concept is that you place thin metal spacers or washers to the bottoms and tops of the gear axles. This is an example of what a shim would look like, pretty basic. Probably most of you already know what this is, and you add it to the bottoms and tops of the gear axles. The reason why this should be done is that it will result in better meshing and engagement of the gears and less vertical play between the gears, bushings, and bearings themselves. This will result in increased efficiency, trigger response, sound, rate of fire, and durability, among more. Now that you guys know the basics, I'll move on to the materials that you will need to complete the process. I like to use a small pick or a screwdriver for checking bevel to pinion movement, and I'll explain this later. Also, obviously, you'll need tools for disassembly, such as Allen keys and screwdrivers, and obviously you'll need a pack of shims. So I like to use SHS shims. They just seem to have good tolerances and they're pretty flat and just good quality in general. They also come with a 0.15 millimeter shim, which is useful for more precise shimming. Two more helpful tools that I like to have near me when I'm shimming is a digital caliper, which can be used to measure shims in case you're not sure what the thickness of the shim that you're trying to use is. And I also like to use a razor blade because it's helpful for removing stuck shims off of gear axles, because sometimes it's hard to get them off. Now that you know the basics of shimming and what you will need, I'll move on to a quick summary of the process. The only correct way to shim a gearbox is to start by adjusting motor height, followed by shimming the bevel gear, then spur gear, and finally the sector gear. This will allow for the most important transfer of energy between the bevel to pinion to be at the proper meshing and spacing. Once the motor is adjusted to line up with the back of the bevel gear, you'll need to position the bevel gear so that it is close enough to the pinion to have full tooth contact, but not be pushed up against it. Basically, what I mean by that is that the back of the teeth should be right there, just so it's not jammed up too far into the bevel gear, but you don't want it like this, because then it won't have full tooth contact. So you want it right lined up with the back, and I'll show this in more detail later. But you also want it to have the bevel gear, actually, in terms of shimming the height of it, you want it to be far enough down against the pinion so that you'll have full tooth contact, but you don't want the pinion gear to be jammed up against it, because then it'll make it hard to turn and will wear your gears down fast. Alright, so once the motor is adjusted to the back of the bevel gear and you shim the bevel gear height to it, then what you have to do is shim the spur. Well, first you have to shim the bevel gear to the gearbox, so that's basically shimming vertical movement without the motor in, and that's just so it doesn't have a lot of up and down play when you're shooting. Okay, so before you start shimming, there's a few prerequisites that you should take care of. You should make sure that you've glued or epoxied the bushings into place, just into the shell. I recommend epoxying because super glue doesn't really stay very well under stress. Bearings, you should probably also epoxy into, but some people don't. If they're a snug fit, you don't have to, but that's kind of up to you. You can do some more research on that yourself, but I'll say that bushings definitely should be epoxied. Also make sure that the inside is flush with the shell, so you don't want the bushings to be protruding into the shell. If they are doing that, sometimes it's fine, but you may not have enough space to shim, so you can grind or shave them down if necessary. So since this is a tutorial with spare parts, I won't be doing this in the video, but you should be doing this for yourself if you're actually shimming. And then if your gearbox shell does not have a cutout in it already, this cutout right here, for checking bevel to pinion, then you'll need to cut that in yourself with a Dremel or whatever kind of other tool you want. If you don't have the cutout, you can also stick a long screwdriver through the top and try and adjust it that way, but I prefer just to have the cutout, it's easier. Or not adjust it, I meant to just say check side to side bevel to pinion play, which I'll show you how to do later, but obviously. But you'll also need a grip that's not messing with your shimming, so you don't want it to be causing misalignment or height issues. So you'll have to find a grip. Most normal M4 grips will be fine, but Meiki or I'm not really sure how to pronounce his name, but he has a great guide on shaving down the grip and checking if you need to, so that it won't throw off the height of your shimming. And so once you've dealt with that, you should also make sure that the screw for the motor height adjustment is not too loose, because if it's too loose, it'll come unadjusted when you're actually shooting the gun, and it'll kind of throw off your shimming. So you can wrap Teflon tape around the actual threads of this screw. You have to take it out and then wrap the Teflon tape around it. And if you don't want to do that, then you can use blue Loctite. I think that's medium strength Loctite, but you shouldn't use anything that's really gonna keep it in there too tight. Like, you shouldn't have to use heat to get it out, but you just want to keep it so it won't come out when you don't want it to. So additionally, all previous shims should be removed from the shell when you're going to do your shimming yourself. You just don't want to have to really deal with that. It'll just clutter everything up, and you just want to start fresh if you're re-shimming. And you should also make sure the whole gearbox is cleaned and decreased to give you a nice area to work with. Okay, so now on to the first actual step of shimming. You should take your bevel gear and place it into the top of the gearbox shell with no shims in it. So this is the top side. Just place it into its bushing or bearing. Sorry, I'm having so much trouble with that, but yeah. So then take your pistol grip and screw the one screw in so that it's screwed into the top of the gearbox shell. Then you're gonna need to take your motor plate once the grip. First you're gonna need to take your motor and just put it into the motor grip, which would be attached to the gearbox, and then put your motor plate motor plate on and screw that in, and then start to adjust the motor height. And what you want is for the back of the pinion to basically line up with the back of the bevel gear, and I'll get a more zoomed in shot of that in a minute. So this would be a good time to install your thread locker if you're going to do that, because this is when you're actually going to be adjusting the height. And you can also choose to drill a hole into the top of the gearbox shell, or well, into right here. You can choose to drill a hole right here so that you can check motor height with both shells in to eliminate variables, I guess, but I don't really find this to be necessary usually. I never really do that. I just adjust it with the top shell only with the bevel gear in, and now obviously you just turn the motor height adjustment screw until the back of the pinion is lined up with the back of the bevel, and I'll have a shot of that right now. Okay, so now you should roughly check how many shims you think will be needed to fill the vertical gap between the actual pinion. See how I'm lifting that up? Between the pinion and the actual pinion gear that's in there. So you can just move it side to side. You should have just a little bit of play. Or you can also push up on the bottom of the bushing right here, and you can just test play that way to see how much actual space there is. This is just for estimating, and once you've made your estimate, put those shims onto the top. This is the top flat side. This is the only thing we're going to be using when we're shimming the bevel gear to the pinion gear. So put those amount of shims you think you'll need onto the top of here. And then once you're done with that, you can move on to the next step. Okay, now that once you've made your estimate of the amount of shims that you're going to need, you'll place the bevel gear into the bottom half of the shell like you normally would, and with only its top side shim, like I said. And then you're going to put the top half of the shell on, and then you're going to, for me, I have to flip it over because it's G&G, but then screw in at least just 3 screws into the gearbox. Once you have that with the bevel gear in, then you're going to need to install the motor grip onto the actual gearbox, then put in the motor, put in the motor plate with your already adjusted screw for motor height, then screw on the motor plate. And what you're going to need to do is take a small screwdriver to the cutout in the shell, like this, and you're going to need to check for side-to-side movement of the bevel. And you should keep checking and then rotate the bevel gear again, keep rotating it, and then check the side-to-side movement again. And basically what you want is to have the smallest amount of side-to-side play possible. So you want to keep adding shims to the top side of the bevel, the large flat side, which is the top, until you get the smallest amount of side-to-side movement possible, but you always want to have some movement. No matter how many times you rotate the bevel, there should always be some movement. So sometimes you may have the perfect amount of side-to-side movement of the bevel, and then you rotate the bevel a few times, and it's just the tiniest bit too tight, resulting in contact between the top of the pinion tooth and bevel. Basically, the pinion in this case would be pushed up against the bevel, and this means that the pinion is too tight. This change in side-to-side play, or like inconsistencies, can be caused by a very slight bend in the motor shaft or slight tolerance issues on the bevel end or pinion. Either way, this isn't really a big issue if you just shim it correctly, and this is still considered too tight, like I said, so you will need to remove a small amount of shims if this is the case. What you want is for there to be a very small, the smallest possible amount of side-to-side movement between the bevel gear and the pinion gear, no matter how many times you rotate the bevel. You should not have to use force to see this kind of side-to-side movement. It should just be very light, and you should just see a little bit, and I'll have a clip of this later. But basically the way that I find the right amount of play is by continuing to add shims to the top of the bevel until I see that it gets to what I would be considered too tight. Then I take my smallest shim off, and usually that's basically perfect shimming. But I'll show you what to look for so that you know you have perfect shimming and this perfect amount of side-to-side play. So you obviously should just keep removing and adding shims as necessary until you achieve the perfect shimming like that I already described. Alright, so after this I'm going to show an example of what you want exactly when shimming the bevel to pinion. So it's a bit of side-to-side movement of the bevel no matter how many times you rotate the bevel, and it should never become bound up. The bevel gear should never become bound up and become tight. There should always be a very slight amount of up and down movement of the bevel between the shell and the pinion, but sometimes this isn't even really noticeable, so you should focus on the side-to-side movement of the bevel gear like this. And obviously, like I said, I'll show an example of this in a minute of what perfect shimming would be. But just keep rotating the bevel, like I said, and then test again, rotate again, and you want to keep rotating it many, many times until you get, there's always a very small amount of side-to-side play. Once you've done that, you'll have perfect bevel to pinion shimming. Okay, so now that you've seen what a perfect scenario basically a beveled pinion will look like, after this I'll show you a scenario that's not good, where your bevel seems perfectly shimmed, but it tricks you, and if you rotate the bevel a few times, the bevel gear will actually get bound up with the pinion gear and then will be too tight. This is bad. You do not want this, even though it might seem good at first glance. The pinion gear might wear into the bevel gear during use if you set it up like this, which would, I guess, solve the problem, but it's not designed for this to happen, and you never want to cause wear on purpose. So, again, this is not what you want, and if you get this, you should probably take this small shim increment you have off and then test again. So, this is not horrible, like I said, but I would still consider this to be slightly too tight. I've seen other tutorials where people show that this is the perfect amount of side-to-side play and perfect shimming, but it's really not. It's still too tight, so I'll show a clip of this. Okay, so congratulations, you finished the hardest part, and you're just going to want to keep working through this until you get the perfect shimming. If you just persist and follow this guide, then it's basic. Shimming is pretty basic if you know the concept, and after this video, you should know the concept of how to shim the beveled pinion properly, and also the rest of the gearbox shelf. We haven't gotten to that yet, obviously, but yeah, you should just, if you just keep rewatching what I already showed, you just keep experimenting with the amount of shims you need until you get that perfect amount of side-to-side play. And so now that you have the perfect shimming, at least hopefully you do, with beveled pinion, this would be a good time to stop and record the total thickness, or basically amount of shims you have on the top side of the bevel gear, and then just write it down or whatever you want, and then completely disassemble this whole apparatus like this. Okay, so the next step is to place the bevel gear with its top side shims into the bottom of the shell. You will not touch the shims on the top side of the bevel at all anymore because we're done with that. Then put the other shell half on and screw in your screws. So then screw in 3 screws like I said, with just the bevel gear in. And then you're just going to want to test up and down movement, and then use inside the bushings, like you can hear that, lots of movement, so you're going to need to obviously add a lot of shims to the bottom, which is the smaller side of the bevel. And so basically just estimate the amount of shims you will need. After that, you should unscrew the gearbox and take off the top shell, and then add the amount of shims you estimated to the bevel, and then close the shell again. If you guess perfectly, there should be a very small amount of up and down movement between the bushings, but you should be able to spin the bevel gear freely. There should be about 3 rotations just on one good spin. Much like the previous shimming you already did, the same concept applies. There should be the smallest amount of vertical movement possible while still always having some. If you have no movement, the bevel gear will be too tightly shimmed to the gearbox. And so now I'll show basically what I just described. Okay, so a quick general tip that kind of applies to the whole process of shimming is that whenever you are testing for movement or shimming with the shell closed, at least 3 screws should be fastened in the general direction of where you're shimming down to mimic the conditions when the gun is fired. Alright, the next step is to now unscrew the gearbox and install your spur gear. You should leave your bevel inside with all of its shims, although we will not be changing its shimming at all anymore. You want to keep adding shims to the bottom of the spur gear until it is sitting just below the face of the bevel gear. Once again, you want it as close as possible, but there should still be some space. You should be able to see light through the gap. Finally, you can take out the bevel gear with all of its shims and put it somewhere safe. Now you need to screw the gearbox together again and check vertical movement. The same principles applied as when you were shimming the vertical movement of the bevel gear. Guess the amount of shims needed to fill the gap between the spur gear and the gearbox. Add that amount of shims, screw the gearbox together, and test. You want the smallest amount of play possible, up and down, while still being able to spin the gear very freely. You should keep adding and removing shims until you get the smallest amount possible of up and down play. Usually I just keep adding shims until it's too tight, then I take off my smallest shim and that will get me perfect shimming. But always remember to test afterwards just to make sure you have perfect shimming. Okay, so the next step is to take apart the gearbox and leave the spur gear in with all of its shims. Next, put in the sector gear and add shims to the bottom side until the sector gear is riding right on top of the spur. It should be just high enough that the faces of the sector don't rub against the spur. It should be close enough though that there is still maximum tooth contact between the spur teeth and the sector teeth. You should once again be able to see a bit of light through the gap. And like I've been doing this whole video, I'll show an example of what I mean in a minute. Okay, now, so on to step 6 if you've been counting. Now take the spur gear out and put it somewhere safe. You must now shim the sector gear to the shell using the same method already described. When I say shim it to the shell, I mean test the vertical movement and make sure that it can only spin freely. Make sure that it can spin freely, but just has a very small amount of vertical movement. Just like the other two gears, you should only add shims to the side that hasn't been shimmed yet, which in this case is the top side. Test for free spinning and little vertical movement. Okay, so now on to the tests. Put all 3 gears into the gearbox, screw the shell together, and spin the sector gear with your hand through the hole in the gearbox. So, just like this. If you have the sector gear in, just spin it like this. So, what you want is for there to be about 5 or more rotations if you're using bushings. You should get many more rotations of all the gears if using bearings. But when I say 5 rotations, I mean of the sector gear, but all of the gears will be spinning. So, yeah. So you should get many more rotations if using bearings, obviously, because there's less friction. And if you hear a loud screeching, squealing noise or whatever, well, basically just screeching and squealing, and the gears suddenly come to like a sharp stop, then you're most likely getting something called zipping. And this is a result of the gear axles being slightly off spec to the bushing holes. And this may have happened at any time during your testing, but the fix for this is to add grease to the axles, the gears, and the bushings and bearings themselves. I prefer to use Super Lube synthetic grease for this, so Super Lube synthetic grease, and like I said, just add the grease to the axles just at the tops and bottoms, and then, like I said, to the bushings, the actual face of the bushings. Okay, now so for test 2, you'll need to install the selector plate and cutoff lever for this. You must then put in the sector gear and make sure that it's not scraping on the cutoff lever, and that the sector gear properly engages it still. If you have problems with this, you may have to slightly move around the shims on the sector. Try to avoid this though. Usually there's only a problem with the cutoff sensor. Usually this is only a problem with the cutoff sensor on advanced MOSFETs such as the BTC FETs. With those, you need to make sure that the sector is shimmed low enough to engage it. Obviously, again, make sure that the sector gear isn't pushing down on it when it shouldn't be, because you could cause to wear, or if you're using a MOSFET like BTC, you could easily break the board. Okay, so this next test involves the piston. Keep the sector gear in the gearbox with its shims and test its engagement with the piston teeth. It should be getting good tooth contact with the piston. It will almost always be engaging just the top half of the piston teeth. As long as the sector gear has around 75% of tooth contact with the piston teeth, you should be good to go. Now finally for the final test, and basically the final part of shimming. So now assemble the whole gearbox or even the whole gun and shoot it. You shouldn't hear any loud screeching, squealing, whining, or grinding noises. Some gear noise is normal depending on your setup, but it shouldn't sound bad. It should sound like a healthy gearbox. If it sounds bad, then you probably messed something up along the way. Most of the sound comes from beveled pinions, so I'd check that first. If you've made sure that everything is shimmed properly and you are still getting bad noises when you shoot, it would be wise to look into your pistol grip causing misalignment or height issues with the motor. Another factor is the compatibility between your pinion gear and bevel gear. Some brands just don't mesh well together no matter how you shim them. If this is the case, you should install a pinion that is the same brand as the gears you're using. You will have to reshim if you replace the pinion or motor though. But just to watch out, Lonex pinions seem to have lots of problems with this. And also aim top pinions, which is horrible. They're like completely off spec to every other kind of gear, so I would just avoid those completely. But SHS pinions are really nice. They mesh well with lots of gears, and especially SHS gears. But yeah, it's just another thing to watch out for.